In this video, we will try to solve a homework problem in my Open Math that requires us to find the zeros of a polynomial function. We will start with the rational zeros of f of x. All possible choices are fractions with factors of 6 in the numerator and factors of 4 in the denominator. So the possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, and plus or minus 3/4. When I graph the function in the calculator, it seems that the graph crosses the x-axis at x equals +1. So this seems to be one of the zeros. I will try to see if I can verify that +1 is a zero. I will either perform long division by x minus 1 or synthetic division by 1. For this example, I will try synthetic division. Write the coefficients of f of x at the top line of the division table. -12, 14 and -6, and the one outside. Drop the 4, multiply 4 times 1, add -2 plus 4, that equals -8, multiply -8 times 1, add 14 with -8, which is 6, multiply 6 times 1, add -6 and 6. The remainder is 0, and it verifies that 1 is the zero of f of x. The coefficients of the quotient show up in the bottom row and correspond to a polynomial of degree 2 written in standard form. The quotient is 4x squared minus 8x plus 6. We cannot factor this quadratic, so we will use the quadratic formula to find its zeros. (b plus or minus square root of b squared minus 4ac divided by 2a. A is equal to 4, b is equal to -8, and c is equal to 6. So the zeros will be 8 plus or minus square root of 8 squared minus 4 times 4 times 6 divided by 2 times 4, which is equal to 8. The discriminant under the square root is -32. And the numerator now is 8 plus or minus the square root of -32, which can be simplified as 8 plus or minus 4i square root of 2. After simplifying both terms with the denominator, we get 8 over 8 equals 1 plus or minus I square root of 2 divided by 2. Therefore, the three zeros of the polynomial are 1, 1 plus I square root of 2 divided by 2, 1 minus I square root of 2 divided by 2.